Hello everyone, how is everyone doing? I hope everyone is doing great. And today we are going to see system designing. We shall start with this simple system. Okay, so let's get into that. So we have a front end and we have a back end. This is basically an API service. So we are building it for an e-commerce. So an e-commerce will have some components like it will have products, users, orders, notifications, and delivery system. Okay, so from the front end, the user will basically send request to the back end, and back end will respond with data, okay, to the front end, and front end will basically represent the data. So of course we need a database. In that database, all the tables for the products, users, orders, notifications, and deliveries will be there, and basically back end will query the data from the database. It will give back the data, and then it will send the data to the front end. Okay, and see, this is a workable application. It will work from the front end. If it sends a request, it will give the data. Okay, and the e-commerce application will run. So that's it. This is the design. See you in the next lecture. I'm just kidding. Okay, so here this architecture, this is basically called a monolithic architecture. Okay, what is monolithic architecture? Monolithic architecture basically means everything together. Okay, suppose like you have only one database, and this database will hold all the tables, all the information, all the data. Okay, and you will have only one backend API service. All the APIs will be implemented in one API service. Okay, this is monolithic application. Now, what is the benefit and what is the drawback of this architecture? The benefit is basically this architecture is quite simple, so it is easy to manage. Drawback is if the database is down for some reason, your whole application is down, user will not see anything. Okay, if the backend API is down for some reason, the whole application is down. Okay, that's the problem with the monolithic architecture. Also, it is hard to scale the monolithic architecture. Suppose for now you are having 10,000 requests per second, and your server can handle 10,000 users per second. That's good. But the problem will arise when your user base will grow and the per second request is increasing. Suppose like it increased to 50K. Okay. But your server can handle only 10K. So you need to scale your server. Now the scaling can be done in several ways. Okay. One is vertical scaling, one is horizontal scaling. What is vertical scaling? What is horizontal scaling? Let's talk about that. See, this server, it can handle right now 10,000 user per second. Okay. 10,000 requests per second basically. And now it is having 50,000 requests per second. So we can increase the RAM, we can increase the CPU. Okay, many more core can be added to process the data. So it will be able to handle more requests. That's vertical scaling. Okay, but at some point you cannot scale vertically. Okay, because the price will be very, very high. You can have 10 GB RAM or 20 GB RAM or max 50 GB RAM. How much RAM will you increase? Okay, sometimes that's not feasible. In that case, what we shall do basically, rather than using one server, we shall use multiple servers and we will host the same application. Okay, so there are 50,000 requests per second and 10K request can be handled by these servers. So if we just host this in 5 of these, like 1, 2, 3, 4, 5, in 5 servers, it can handle 50,000 requests very easily. That is horizontal scaling. Okay, so let's scale it to 5 servers. Now see, I have hosted the same application in 1, 2, 3, 4, 5 servers, and each can handle 10,000. So it can easily handle this 50,000 requests per second. Okay, now we scaled our application, and this is still monolithic application because one server is holding everything. Okay, many developers think that monolithic cannot be scaled. Monolithic can be scaled, but to a certain extent, to a certain point. But after that, it cannot be extended. In that case, we need to break it. Okay, now from the front end, the request will go to which server? Will it go to this server or this server or this server, or which server it will go to? Okay, for that decision, we need a load balancer in between that will basically distribute the request among the servers. Okay, so let's introduce a load balancer in our system design. So this is our load balancer. Okay, now from the front end, the request will go to the load balancer, and load balancer will remain connected with all the servers. So the load balancer will basically distribute the request to the servers. And how will it distribute? It depends on the load balancer algorithm. There are many kind of algorithm like round robin algorithm, weighted round robin algorithm, list connection algorithm, weighted list connection algorithm, or you can even develop your own custom algorithm for the load balancer. Okay. Now see, if the load balancer, it distributes the request 10,000 requests per server, now it can easily handle 50,000 requests. Okay, basically this number of requests. So our application is scaled, it will work. But still the problem is there is only one database. Now for some reason, if one server is down, it will still work. These servers are working. Okay, they are giving the same service. Even if two servers are down, still three servers are working. That's good. Okay, but if the database is down, your application is down. So this is still a problem with monolithic architecture. Okay, so what we can do? We can go to microservice architecture. What is microservice architecture? See, your application will have multiple services. Like you have these products, users, orders, notification, on delivery service. In reality, you will have many more services. But for simplicity's sake, we have only 5 services. Okay. Now, if we create an API service only for the products, basically, if we take this product service out of all of these, and if we take the tables out of this database which are connected to the products, and if we create a new database for this service only, it will be a microservice. Okay, so let's do that. Let's make it microservice architecture. So here we shall have only products. We shall remove the rest of the thing, and it will have its own database. Okay, so this database will only hold the product related tables. Okay, same for this service. We'll remove all of the service except the users, and it will have its own database. Okay, with its own tables. So okay, now you can see that this service is only holding the products and its database. It is holding only the users and its database, and so on. Okay, now we can remove this database. Okay, we do not need this. We have broken it. Now we can call these, all of them are microservice. Okay, so every single service and its own database. Remember, so in microservice architecture, of course, the database will be broken and the services will be broken. So this is microservice architecture. Okay, now is it a workable microservice architecture? Will it work? No, it will not work. Okay, why will it not work? Now from the front end, when the request will go, we do not need a load balancer here. What load balancer does, basically, it distributes the requests just among the servers. But right now, we do not just need distribution. We need to pinpoint which request will go to which service. That's very important here. Okay, so what will happen basically? So here we basically need an API gateway. So let's create an API gateway. Okay, so here we have the API gateway. Great. Now, what this API gateway will do, it will basically look at the incoming request from the front end. So the request will hold an URL, and the URL will be something like this: example.com/users/some resource. Okay. Now it will look at some part of the URL and it will decide where to send the request. It saw that it is actually for the user service, so it will send the request to the users. So API gateway will look at the request URL or some other information of the request, and then it will decide where to forward that request. Suppose we need to forward that to this user service. Okay, so this is how the API gateway works. Is our microservice workable now? No, it is still not fully workable. Why? Because see, even if we have separated, basically we have made these services independent, still they are connected logically. Okay, why? See, if the user want to order, what the user will order? User will order definitely products. So sometimes this product service and this order service, they need to communicate with each other. They need to talk to each other. Okay, or maybe the user service and the order service, they need to communicate with each other. So for that we need some sort of communication system among them. Okay, so generally for that a message queuing service is used. Okay, there are many message queuing service like RabbitMQ, or there is Kafka and many more. Okay, so here we are using RabbitMQ. So all of the services, they all remain connected with this RabbitMQ. Okay, and now through the RabbitMQ service, they will communicate with each other. All right, so let's make the communication happen among them. Easy to workable now. This microservice architecture, easy to workable now. Now it is workable. Okay. Now from the front end, the user will send the request to the API gateway, and the API gateway will decide where to send the request. And if that service need to communicate with some other service, it can communicate with RabbitMQ. Now it will work. Okay, this is core components of microservice architecture. Now, what is the benefit of this? The benefit is if this database is down, if this service is down, still this service is working, this database is working, they are working. Okay, so these four services now they can provide service to the front end. Okay, if two services are down, like this service, they are down, still three services are working. Your application's availability increased. Your application is more robust now, more strong now. It cannot be killed easily. Okay, so it will give a very good experience to the user, even if some services are down. If the user goes to the website and sees nothing, that's a very bad experience. If the user sees something, that's at least better. Okay, what is the problem with this architecture? The problem is the architecture, you can already see it's complex. Okay, so it will be hard to manage. So always for businesses, my recommendation is if it is a small business or medium business, always start with the monolithic architecture. But do the monolithic architecture in such a way that it can be converted to the microservice if it is needed, so that it doesn't take much time. Okay, but still it will take time because its architecture is much more complex than the monolithic architecture. Okay, but for the enterprise level application, microservice architecture is a very good solution. Now see, this application is more scalable. How is it scalable? See, I can now scale it like on service level. For some reason, if I see that this product service is getting most of the requests, so what I did, I used a load balancer here, and like there are multiple product server, so I can just distribute the load among these servers using a load balancer only for this service, only for this product service. Okay, that's possible now. So let's do that here. So these are the product service. If we zoom, we will see that these are the product service. Okay, so now we can use a load balancer here. And from the API gateway, the request will go to the load balancer, and the load balancer will basically distribute the load among the servers. Okay, and they are all connected with this database. Also, they are all connected to this RabbitMQ. See, our application is more scalable now, but also the complexity is increasing. Now, suppose for these products, basically, let's zoom it. So, this product service here, see, from the front end, people search a lot for the products. Okay, so like if you have 100,000 product in the database here, and somebody is searching like for a notebook, then this notebook will be matched with every single product name. Okay, and it will try to find out whichever products are actually holding the product name, basically notebook. Okay, now think about this. For every single search, if you are matching with every single product, how much time will it take? People will search and it will keep loading, user will go away. Okay, that is what will happen. If the user waits 10 seconds for a search, people will not use your application. So for that, what we can do, basically, we can do indexing. Indexing, what is indexing? Indexing is basically, if you create an index for the product name of the product table, what it will do, basically, it will sort the product name. Okay, so if it is sorting, then binary search can be used, which will drastically reduce the searching time. So that's the benefit of indexing. So let's do indexing to this table. Basically, let's create an index for the product name. Okay, but still see, it will match the string. Okay, suppose if you are searching for notebook, it will only match the notebook, but there are many products can be named with laptop. They are synonymous words. Okay, or maybe user is searching for laptop, but user made a typo. Okay, basically typing mistake and product could not be found. That's not a good experience for the user. User can make a mistake. Okay, or user can search with synonymous words. For this kind of solution and for a better searching experience, we can use elastic searching. Okay, so let's use a service called elastic searching, and let's connect the products with this elastic search. Okay, this is very, very efficient. So see, whenever you will create a product, okay, basically you are inserting a product in the database. So it will insert the product in the database, and it will also basically insert all the information of that product and its synonymous words, everything in the Elasticsearching service. Okay. And that way, Elasticsearch will have the information of the products. And now user can search using the Elasticsearch, and that is very, very efficient. Okay. So we have used many services already. We have used database indexing. We have used Elasticsearch. Now let's use a cache service. Okay. Like for this user, basically with the user service, user will try to authenticate, user will have a session. Okay. So you need to save the session somewhere. Rather than saving it in the database, you can save it in the Redis cache. Okay. Redis is basically an in-memory database. So it retrieves the data very fast. It saves the data very fast. And as it is in memory, of course, it is volatile. So you can store temporary data in the Redis service. Okay. So let's use a Redis service here with our user service. Okay, so far so good. Now our service is more robust. Okay, now think about this delivery service. Okay, now let's think that this delivery service, it is basically tracking the location of the delivery boy. Okay, in reality it can have a lot of requests per second, like it is having 500,000 requests per second or 1 million requests per second. Your server cannot handle that. Now if you think that you will use a load balancer here and you will increase the server number, it will not work. Why? Because how many servers will you increase? If the number of requests that are coming, that is insane amount of requests, then rather than scaling it horizontally or vertically, it's better to use a message queuing service in between. What it will do basically, it will save all the incoming requests. Okay, and queue is basically first in first out. So whichever request came first, that will be served to the server first. So we can use a Kafka service here. Now see, now if we need more servers, we can use a load balancer in front of the Kafka. Okay, so I can have multiple service here, and from the load balancer, it will send the request to these services. Okay, so that is also possible. Now you can see that this system designing thing is a very creative thing. You cannot just say, I know this kind of system and all of the systems will work like this. No, that's not gonna happen. Okay, so according to your need, according to the budget, according to the requirement, your system will be designed. And budget is very, very important thing. You can design a very robust system, but if your budget is low, it is not practical. See, even we can use a load balancer here. Okay, and multiple API gateway. So from this load balancer, now we can distribute the load to multiple API gateways. That is also possible if we need that. Now think about this, that this service, it is suppose hosted in a particular region, like it is hosted in Asia. Okay, now the user who is in Europe, how will he access this? The user from the Europe, if he access that services that are hosted in the Asia region, then there will be latency. Okay, the data will have to travel a long path through the ocean, and then the response will come. So user will have a bad experience because it will load for some time. So what is done basically, the same architecture, we can host this in a different region, like we can host in the Europe. So let's host it in the Europe. So this is in Asia. Now we need one in Europe. So this is in Europe. Okay. Now, when the request will be sent, where will it go? Will it go to this region or this region? Okay. So first we need to decide basically the user who is requesting a service, what is his nearest location? If the user is in Europe, then the request will be sent to the Europe. If the user is in Asia, that will be sent to the Asia. Okay. So for that, we need a special load balancer here. Remember one thing, that whatever request we send, okay, it definitely goes through a DNS server. Okay, what is a DNS server? DNS server basically resolves domain name. Okay, suppose you are going to google.com. So google.com, it will go to a DNS server. From the DNS server, it will actually find out the IP of the Google server, and in that IP, the request will be sent. Okay, so let's draw a DNS server. So now the request will go to this DNS server, and then the DNS server will resolve the domain name. Okay, now there is a load balancer called DNS load balancer. And this load balancer, it can be used for the geolocation of the user. If the user's IP's geolocation is somewhere near the Europe, and it will send the request in the Europe region. If it sees the user's location, basically user's IP's location is near this Asia region, then it will send to the Asia. Okay, so let's connect them. Okay, so DNS load balancer, it will decide in which region to send the request. Okay, now we have hosted our application in different region and it was working. Now will it work? It will not work now. Why? Because see here, basically every single service has a database. Okay, so here in a different region, it also has a copy of the database. Now, if the user sends a request to this region, basically Europe, it inserts an information in the DB, the user DB. In the another region, we do not have that data. Suppose you have registered for an application when you are in Asia, and tomorrow you move to Europe. When you are in Europe, that database is different. After registering yesterday, if you see tomorrow in a different region, you have no registration. I mean, that's not a good experience for the user. So for that, we need some sort of data replication system. Basically, same database will have some kind of replication system. If one data is inserted here, it will be replicated here as well. Okay. And when you do so, there can be many more complexities out of that. Okay, so not only the database, the Elasticsearch service, the other service replication system has to be implemented now. So that will bring more complexity in the system. So this is how basically the system designing is done. And in the system design series, I shall try to explain how the load balancer, API gateway, and the other services, how do they actually work. Okay, I'll try to explain them in details in this series. And please subscribe and hit the like button. This is very important to us. Okay. And that's it for today. Take care of your health, keep growing your knowledge, and keep applying your knowledge.